Hello and welcome to the second video in this series where we're learning how to balance chemical equations. We're taking it step by step, line upon line, precept upon precept. Well, in this video, we're talking about why the concept of balancing chemical equations matter. Why does it even matter? Well, we're learning about that in this video. Let's get into what we have got. So I'm starting off with a question. Imagine five students enter a classroom. Now we have the illustration of a classroom setting on the screen right now. Here is the teacher, and here are the students. One, two, three, four, and five. Five of them enter a classroom, and then suddenly, during the period when it was time to take attendance, the teacher counts 10 students. What comes to your mind? Where did the extra five students come from? Because what entered into the classroom is not what is being counted in the classroom right now. In the same way, chemical equations work like that. The number of atoms or the amount of substances that begin a chemical reaction must be the same with the amount of substance that ends the chemical reaction. If one is higher than the other, then it is not balanced. So you can see how this works. You'd be asking, how did extra five students enter the class? So that same idea happens in chemistry. When chemical reactions happen, the atoms that take place in the reaction are not created, new atoms are not created, and atoms are not destroyed either. These two statements make up something that is called the law of conservation of matter or conservation of mass, whichever one you choose to call it. The law of conservation of mass. So atoms are not created and they are not destroyed, they only rearrange themselves. This is the main reason chemical equations must be balanced. In other words, what is contained on the left side must be equal to what is contained on the right hand side. Here is another illustration. If you begin a chemical equation with 8 atoms, what you must end with must be 8 atoms as well, because no new atoms are created or destroyed in the process of the chemical reaction taking place. I hope you're getting value for what you're hearing right now. So, for example, when hydrogen reacts with oxygen to form water, we have the chemical equation on the screen right now. On the left hand side, let's count the number of atoms that we have. So we have hydrogen over here, H2. Now you can see this number 2 telling us the number of atoms that hydrogen has present, which is 2. So we have 2 atoms of hydrogen on the left hand side. And then oxygen, O2. The number 2 here tells us that there are 2 atoms of oxygen present. So we have 2 atoms of oxygen on the left hand side. How about on the right hand side? We have H2O. This 2 here belongs to hydrogen. So it tells us that there are 2 atoms of hydrogen on the right hand side. But oxygen, you can see over here, has just 1 atom. So on the right hand side, oxygen has just 1 atom. What does this mean? It means the chemical equation is not balanced, because what is on the left hand side for oxygen, O2, is not the same for what is on the right hand side for oxygen, which is just O. So you can see the chemical equation not being balanced in this case. That tells us that a chemical equation must be balanced, and it is balanced when it has the same number of each atom on both sides. The previous equation that we looked at, we saw H2, hydrogen, plus oxygen, O2, yielding water, H2O. Our aim is to make sure that this chemical equation is balanced, and we've seen that oxygen has 2 on the left hand side and just 1 atom on the right hand side. So to fix the equation, how do we balance it? Well, we balance it by introducing something called a coefficient. We're going to be learning what these words mean as we proceed in this series. Okay, so we introduce something called a coefficient. We introduce a coefficient over here and we introduce a coefficient over here. That way the chemical equation becomes balanced. Now let's count the number of atoms of hydrogen that we have on the left hand side. So on the left hand side over here you can see hydrogen. There are two atoms over here and there is a coefficient of 2 over here. So when 2 multiplies 2, we have 4 atoms of hydrogen. Let's write that down. On the left hand side over here, you can see oxygen has 2 atoms. How about on the right hand side? You can see over here hydrogen having a subscript of 2 and a coefficient of 2. When 2 multiplies 2, it gives us 4. And then this coefficient affects everything after it. We have 2 atoms of oxygen. So you can see at this point that this equation is balanced. Don't worry if this example that I just showed to you confused you in any way. We're going to be going over it step by step. I just brought this up to clarify a few things. I hope you're getting value for what you're watching on this video. So what we just saw right now is something called the law of conservation of mass. It's a big scientific law that says matter cannot be created or destroyed during a chemical equation. What does that mean? It means atoms are not lost. New atoms are not invented, they are only rearranged. Here is the example that we looked at: H2 hydrogen plus oxygen O2 yielding H2O. You can see the arrangement that took place. Over here, hydrogen was standing alone, oxygen was standing alone. But on the right hand side of the equation, you can see that they have been joined together, which is a form of being rearranged. So that's what the law of conservation of mass simply talks about. So here's another simple real life analogy that I believe you can relate with. Suppose you transfer some money to your friend, let's say 10,000 naira. Your bank account cannot be debited for 10,000 naira and then your friend receives 50,000 naira. Something must be wrong somewhere. The amount that you send must be equal to the amount that your friend receives. In the same way, whatever you begin with in a chemical reaction must be equal to what you end with. I know I'm communicating wisdom at this point. So that's what happens in a chemical equation. So here is an important note I need to sound to you, because in the process of balancing chemical equations, you will be introducing new numbers, and I'll show you how in a moment. When balancing chemical equations, never change the small numbers below. The small numbers below are called subscripts. They are called subscripts. You are never to change them. So a very good example is what I want to show to you right now. You can see H2O over here. If it is included in a chemical reaction, you cannot change the small number like from H2O to become H3O. This is not allowed in balancing chemical equations. When balancing chemical equations, you can only change the big numbers in front. Those big numbers in front are called coefficients. So you can see when we were balancing the equation in the first example, H2 plus O2 giving us H2O, we never changed a small number. All we did was to introduce big numbers, coefficients, into the equation. So we're going to be learning about this properly in the next session. I just thought to bring this up to make you aware of what is acceptable in balancing chemical equations. So here's a quick practice session for you to try out your hands on that while we await the next video. Is this equation balanced? I'd like you to let me know in the comment section. So I want you to check out the equation and let me know if it is balanced. List out the elements that are present, and then for each element, count what is on the left hand side and count what is on the right hand side. If what is on the left hand side does not equal what is on the right hand side, then the equation is not balanced. But if they are equal, then the equation is balanced. So do that and let me know what your answers are in the comment section, and I'll be there to give a reply to each and every one of your comments. So right now the video is done. We're moving on to the next one where we get to see the parts of a chemical equation. It's been a pleasure being with you. My name's David, and on this channel all we do is take out the difficulty of chemistry to help you ace your examinations. Thank you, and I'll see you in the next video. God bless you.